Hi, I'm Saili Afle, a PhD candidate here at UT San Antonio. In this video, I'm going to go through the steps to do schematic simulation of an inverter. Well, to start with, this is our library manager of Cadence Virtuoso software. This is the continuation of the previous video. Well, to start with, the first thing I need to do is create a library. The first thing is, so I go to the library manager of Cadence Virtuoso, file, new library. Then I type in my name. So here I type in inverter underscore final underscore one. Well, you can choose whichever name you want to. I'm just choosing final inverter final one. Then I do OK. The next step is that I attach an existing technology library to my created library. So I attach a technology library. I click on attach. I press OK. And then I'm going to get a box in which you will be getting multiple libraries, out of which I am going to choose the GPDK045 library for my inverter. Press apply, press OK. Once that is done, I can go on the tab in the left side and I can search for my library. So if I go here, I click here. This is the library which I created just now, inverter final underscore one. Now, the first thing after creating the library is that I need to create the schematic. So for creating the schematic, I choose my library on this tab. I go to file, I go to new, I go to cell view. Here I type in inv cute. Okay, you can choose the name as per your convenience, but keep in mind here the view should be schematic, the type should be schematic. If you go down, there are multiple options, but because we are doing the schematic, I choose schematic. Then I open with the schematic L, that is the schematic file. Okay, even here there are multiple options, so I choose the schematic L and then I press OK. Yeah. So, as you can see, initially there was no cell view. So on the leftmost side is the library name, the middle block is the cell, and the rightmost block is the view. So I created the cell view. Here, the schematic file you can select by double clicking on it, left click, and the file will be open. The first thing I do is I save it. Okay, here we are going to create our inverter schematic. So we will have a couple of elements, that is the NMOS, PMOS, and the pins, that is VDD, VSS, uh, input pin and output. So in order to import the PMOS and NMOS, I go to create instance. Here I choose the GPDK045 library. I choose the cell as NMOS. Okay, so this is what you will get. Then here in the body type, I choose integrated. And then I left click on hide and I just click once on my screen. And in order to get out of the NMOS or any element, I just press escape from my keyboard. Okay, in order to zoom in, you can just press zoom in buttons from here. Okay, or you can just press F from your keyboard. It will just zoom in to the number of elements or whatever is there on the screen. So Because I need to place multiple other elements, I just zoom out of the screen. Okay, here our NMOS is a 4-terminal device. If I select it using one left click and I press Q, I will get all the elements of it over here displayed. My library which I have used, the cell name, the view name, the instance name, well here it is NM0. You can choose your name. We do not make any changes with the length, width, finger width, total width. Um, we just made the change with the body type, which I chose integrated. Okay, so I just cancel this. The next element which I take is the PMOS, same way. So even here I choose PMOS and I select PMOS. Okay, if you are not able to change the body type while importing the element, you can just select, you can press Q. Again, these parameters will be open for the PMOS. You go back here again, open the body type column, then choose integrated, and then just press apply and OK. So the next step is I do save. Okay. So if I check now, I go Q. Yeah, everything the way I wanted it to be. Okay. The next step is I select the check and save option. See here I get warnings. Well, initially because the 4 terminals of PMOS and NMOS are not connected to any wire and eventually not connected to any port, you will get these warnings. So as you do the connections, these warnings will go away. So here I just press close. And one more thing, if you want to see what are the warnings, you can just go to the TCL console of your Cadence Virtuoso, maximize this, and if you just scroll above, you will get all the warnings here. All the errors, all the warnings, everything, each step is recorded in the TCL console. So if you need to go through any logs, you can just go back here and check them. Okay, so I just minimize this. The next step is I do the wire connections. So for wires, I go here and I select the narrow wire width. Well, you can choose the uh, thicker wire as well, but here I just choose the narrow wire width. Then I click on hide. Then I click once, left click on this terminal, a wire will be extended. And if I have to release the wire, I can just double click on the wire after a certain length, which is desired by me. Again, I choose, I do hide. I just do this. Now, if I just do one click, then it will be a continuation. It's sort of a pause for the continuation of wire if you want to change the direction. But in this case, I do not want to do that. So I just double click on it again and release it. Okay. Then again, I go here and I click and I finish this connection. So here I am connecting the gate terminals of the PMOS and NMOS. Next is I connect the drain terminals of PMOS and SMOS. Then I connect the substrate with the source of PMOS. I connect the substrate with the source of NMOS. That is, I'm shorting the substrate or the bulk of PMOS with its source terminal and NMOS with its source terminal. Okay, then again I save. It's very necessary. It is very necessary to save after every few steps. Um, yeah, then I do check save again. Okay, see now the warnings did not appear because there are some sort of connection. The next is I just take one more wire outside to connect it to the VDD terminal and this to the VSS terminal. After this, and one more to the output terminal. Okay. See now again there are warnings because there are three uh, wires which are without any connection. So I just close them. And then one more wire I'm going to have it for the input terminal. So in this case there are four terminals: VDD, VSS, input, and out. So I just say now for these four terminals I need to create the pin and the label. So I go to pin. Here I type direction input. Okay, I press hide and I just go here and click at this end. So this is my pin and label for the input terminal. I press save. I again go pin VDD as well will be input. I press hide. Yeah. Now two warnings. If I press check and save, one is for output and one is for VSS. I close it. Again I go pin VSS. VSS is also an input terminal. Okay. If you press anywhere in between the wire, it will give you an error because the other end of the wire will not have any connection. So at that point, you will have to delete the wire, the other end. Then for output, I go pin, I do O, I just change the direction to output and I press hide. And I just go and click here. I save, I check save. Now our inverter schematic is ready. You have to make sure that there are no errors when you design your schematic. Okay, and there is no terminal that is open. Yeah. The next step is you create the symbol using the schematic automatically. So I go to create, I go to cell view, from cell view. Okay, this is, I create the symbol. This is my library name, this is my cell name, and this back view is the schematic view. So here it should be schematic, and we need to go to the symbol. So it should be symbol and it should be schematic symbol. Please keep the name same for continuation purposes. And then you press OK. Yeah. Here you have, as we have four terminals, you have four terminals here, but all the four terminals have certain specific predefined dimension. Input dimensions are given left pins or output dimensions are given right pins. But here in our case, we are going to rearrange the direction of the pins, but the pin's nature is going to be the same. So input is I, VDD is also input direction, and VSS is also input direction. It's just that I'm going to change this pin location to for better purposes. The visualization will be better in this case. So my left pin is input, its direction is input. My right pin is output, its direction is output. My top pin is VDD, its direction is input. And my bottom pin is VSS, and its direction is in. Okay, this just specifies the location of the pin. If I press OK, So a symbol will be created for my schematic. Yeah. The first thing I need to do is check and save in this case so that the file is saved in the library manager. So this is my symbol. I keep it as it is. And if I go to library manager now and see, this is on the left side, inverter final one is my main library. Institute is my cell and it has two things. One is the schematic and one is the symbol. Okay. Then I just minimize this. But it is not getting minimized. That's fine. If there are any other unwanted windows, I can just cancel them like this. So I just go here, schematic. Okay, if it is getting minimized, that's fine. Otherwise, you can just go down and open one. Okay, the next step in this is to create the test. So I need to go to the library manager, select my library, go to file, go to new, cell view. Okay, in this case, this will be my test. So I can keep the name of the cell same except just add TB to it to indicate that it's a test bench. Okay, everything else should be the same. Schematic, schematic, schematic L. I press OK. So here a new cell view will be created. This, okay, and that view will be the schematic view. So this is my schematic view for my test bench. In this, I am going to create my test bench using the symbol which we created. Okay, first, as I said, save it so that it gets saved to your main library manager. Then I go to create, I go to instance, and I want to export my inverter file, especially the symbol. Okay, so where did it go? Okay, I'm just gonna cancel this for now and start again. So I go to create instance. Yeah, here I choose my own file, my own library, which I created. That is the inverter final thing. And from this window, the second window, I choose inverter and also be careful that you need to have the library here as the same as the inverter final one. Okay, your view should be symbol and then I select on this symbol name and I just click here. So this is the symbol which was created in the symbol file. If you select this and if you go on this left side, well, I have all the ports and terminals. So it's I, O, VDD, VSS along with the direction. If you go, yeah. So I is input, signal, input, output. Yeah. So as you can see, you can get it here once you select it. Okay. Then I press F in this case. So it just gets maximized. Now, in after this, once you have imported the symbol, you can save it. And here you need to give the sources. So there are three voltage sources. One will be for input, which will be a pulse. Second will be for VDD, which will be a DC voltage of 5 volts. Third will be VSS, which also will be a DC voltage of 0 volt. And apart from this, to get the load, we will take the load on a capacitance. Okay, so first I will take the voltage sources from the analog lib library. So I go create instance here. I change the library from our library to the analog lib library. Then I go here cell and I can go down and choose V source. Okay, V source. Or if I can, yes, I can see V source, so I chose V source. Once you choose V source, these things will be updated. Here I give the name, suppose I. Please try to keep the continuity in the names so that it's easier for you to interpret as well as the software to understand. Okay, here I instead of sine wave, I choose pulse wave. Okay, and in pulse wave, I need to give specific timing, so my delay is going to be 0. My 0 value is 0 volt, 1 value is 5 volt, period is 40 nanosecond, rise time is 1 nanosecond, fall time is 1 nanosecond, and my pulse width is 20 nanoseconds. Okay, once I do this, I press hide, I go back and I click here. Please make sure that you are not connecting any of your voltage sources inside this white box. Okay, even in this case, I hope you understand that in this white box is the boundary of that particular element, and you are not supposed to place any other element inside this white box. Okay, so if I select this and I go on the left hand corner, I get the exact same values as I mentioned here. It's a pulse, delay time is 0. My lower voltage is 0 volt. My upper voltage is 5 volt. So my pulse will go from 0 to 5. My period is 40 nanoseconds. That is the rise time and fall time included is 40 nanoseconds. And my pulse width is 20 nanoseconds. That is the 50%. Okay. After this, I save. Again, I go to create. I go to instance. Now I do VDD. For that, the source can be, the cell can be vSource itself. I just need to change this to DC. And I put 5 over here. So that will be the DC voltage source. That is VDD. Okay, I can, if I need to change this name, I can just select, I can name it here VDD. Okay, and I save again. I check save again. Then I will get warnings because these terminals are not connected everywhere, anywhere. Okay, I close. Then I take the VSS. I change my name here. Okay, VSS will be 0 volts. I hide. Okay, now after this, I take the capacitor instance. Here I just type CAP and I choose capacitance. If it is not changing automatically, just click on this. Okay, click on this box. Then capacitance, I change it to 100.0 AF. Okay, you don't need a lot of big capacitor. I click hide and I just delete this. Okay, here you can see the value of the capacitance. After this, the most important thing is I need to choose the grounding terminal, that is G and D, and then I choose G and D, right? Okay, this G and D needs to be connected to every voltage source and the capacitance. You can choose one GND or two GNDs and connect it commonly, but be careful that you don't have to like cross the wires. Okay, so once this is done, I will do the final connections. Okay, here also I choose the thin wire, I choose high. Okay, so my input voltage is connected to the I terminal and ground. My VDD is connected to the VDD terminal and ground. My VSS is connected to this terminal and ground. My capacitance is connected and ground. Okay, then I save, then I check save. Then as you can see, there are no warnings. Well, it's very necessary to do the connections properly and not get any warnings, because if you do, then it won't do the final simulation. Okay, so once I do this, I save it. Then the next part is the actual simulation of this test bench. Okay, so for that, from this terminal itself or this file itself, I go to launch, I go to EDE Explorer, I create a new file. That file is going to be known as the Maestro file. I press OK. I can just keep the name same, just check that the view is Maestro and press OK. So this Maestro view will be created. Okay. Now, um, again, I save this. Okay. The first step in this is to set up the simulator. So I go to setup. Okay. Yes. So the first thing is that you set up the simulator. So I go to setup, I do simulator, and you choose the Spectre simulator. You apply it and you press OK. See, you on the left hand side, you will see the simulator Spectre setup. The next step is you choose the transient values. So stop time, I will go to 1U. Okay, I will click on moderate and then press OK. Okay, if it should, the analysis should appear here instantly. If it doesn't appear, that's totally fine. We will make sure that it appears later. So again, the next step is then I set up the environment. I check here that it is Spectre and then I press OK. Okay, now I go here, I select on this blue arrow, okay, which will pop up the AD assembler. Okay, but once I cancel this, okay, you don't have to cancel it. You can just go back to your AD Explorer, and after that, you will have your transient set up to 01U moderate and your simulator aspect. Okay, the next thing is to set up your model libraries. So I go to setup, I go to model library. Here you need to import two libraries. Okay, so first you click on this box, then you click here, then these three lines will appear. So you click on these three lines. In your folder, in your main folder, okay, you will have to choose two files. One is the vector file, all models.spectre file. Yes, all models underscore spectre.sc file. This you need to choose, and then one more file, which is all models.sp file. This you need to choose. Then you need to apply, and then you need to press OK. It's very necessary to choose these files for the simulation. Okay. The next step is that you set up your outputs. Okay. So for setting up outputs, we are going to choose them from the selected design. That is our test schematic test. So I go here. Okay. Now my inverter test bench is going to arrive. So I go on this input wire. I select and double click on it. I go on this output wire. I select and double click on it. You can choose any other wire if you want to see that wire's signal. Okay. So I have chosen it. Now I go back to the Maestro window. Now the wire hasn't appeared yet. Okay. So I go to launch. I go to ADE assembler. Okay. The wires hasn't appeared yet here either. So I go back to the launch. Okay. And I repeat the step again. Output to be plotted. Select on design. I do it again. I go back to Maestro. I save. I launch my ED assembler. Yeah. Now the two inverter wires are selected. Sometimes it does not get selected in the first go. That's fine. You don't have to worry about that. You just repeat the step. Then you click on plot and save of these two signals, net 1 and net 2. Okay. Once you select it, you go back to launch, you go back to AD Explorer. The difference between AD Explorer and AD Assembler is just that in AD Explorer, you can simulate it for one output results, and for AD Assembler, you can simulate it for multiple output results. Okay, so once this plot and save are selected, next I do is the simulation. So for that, I need to create the netlist. So I go to simulation netlist, we create. This Spectre out file will be created. Okay, it will have all the files that are included and it should run without any errors. Okay, it will have all your details of what the input is, what the VSS is, what the BTD is. So I just minimize this one. Okay, then I go. If there are any errors uh, that needs to be detected, those errors will be detected in this spectre.out file. Okay, so before running the simulation, I would recommend you to go to just simulation netlist, recreate this netlist and check for any errors or warnings. Okay, then once that is done, you can just do netlist run. Yeah, then again, this vector output file will be generated. Yes, and okay, all the parameters will be completed. Here you will get Spectre complete with 0 errors, 7 warnings, and 7 notices. Warnings are okay, errors are not okay. Okay. Once this is done, you will have one more window popped up, and that is the output window of your simulation. If I go here, this is my simulation output window. Okay, this simulation. Now, initially all the output signals will be displayed on same net, but you can just select it, press right click, and you can just move to a new strip. So now these two signals will be displayed on two different strips. Okay, so in our case, as our signal went from 0 to 5 volts, net 1 is the input and net 2 is the out. Okay, so if I have to like maximize into the signal, I can just do this, or I can just maximize it from here. Okay, um, as per different assignments, you can just choose. which signals you want to display. Okay, you can save these signals as well, save this output file as well, or you cannot choose to save. So every time you need this output file to be displayed, you can just do simulation netlist run. Okay, once this is done. Now, if this file is not automatically getting generated from the netlist run command, I can just go to results, plot outputs, transients, and then again this file will be generated. Okay, now as per the requirement of your assignments, you can just take screenshots of things. Okay, so this is basically the schematic simulation of your inverter. It has a couple of files. Those are schematic file. Yes, this is the schematic file. This is the symbol file. Then this is the test bench schematic file. Yeah, this is the test bench schematic file. And then it is the maestro file. Yeah, this is the maestro file. And then there is the simulation output file. And there is the spectre.output files. Okay, yeah. So here we stop the schematic simulation of our inverter. The next video will have the layout simulation of this inverter, the layout design and the simulation, that is the post layout simulation. Okay, thank you so much.